Hello and good evening, CTS265 Section 840 students for the Fall 2015 semester at Anne Arundel Community College. This is the CCNP route course, and this evening's video tutorial is going to be on challenge number 10, where we're going to have to dig in and configure BGP in a pretty expansive setup here. But we should be familiar with this. Not only is this network architecture very similar to what we've been reading in the text, you should also see that this is actually very similar to what we've just done in the previous discovery activities. So let's go ahead and take a look here. So it says you've been asked to set up BGP in the enterprise that has been assigned AS65000. I'm going to assume if we were to take a look, I think the job aids may have a better... Yeah, there we go. So this is very, very similar to what we've just done. However, take notice here of this third connection into Gateway 1 through the 209.165.201. This was not here before. And so this gateway router is peering with two different providers, whereas Gateway 2 peers with a single provider. And so we've got the same AS numbers as we had before, I believe. So we may come back to that, but let's go ahead and dive in here into the scenario. So the internet service providers, ISP1 and ISP2, have configured the BGP peering on their side. The external BGP session between Gateway 1 and ISP1 must be established between loopback 0 interface of the routers. Now, when you see this, as soon as you see loopback 0 is what the peering is going to be on, and this is an eBGP peering session, you need go no further than ISP1 or the routers that are already configured. If I say show run section BGP, what we're going to see is not only do we have the update source set, but if I were to say show run include route, my guess is exactly that we're probably going to have for the loopback 0 address on Gateway 1, let's take a look and see what that is. Show IP interface brief, and sure enough, loopback 1 is the 192.168.11.1, and actually, I'm sorry, loopback 0 address is what we're looking for, which is 192.168.11. But again, the key being here that if that's what the peering needs to go to, and it's an eBGP peering, not only do we have to have this update source loopback 0, we need to have reachability to that loopback address. Now, it's probably not common in an eBGP peering with a service provider unless you're multi-homed to that service provider that you would peer off the loopback addresses. So again, when we look at the drawing here, we can see in the diagram that Gateway 1 has a single connection that it's peering with here between ISP1 and Gateway 1. So there's really no need to peer with the loopback addresses, because if that interface goes down, and we talked about this in class, if that interface goes down, it doesn't matter that I've got a static route that points to the loopback going this direction. I have no other path to get there, right? So if that path goes down, the peering is going to go down, my reachability is going to go down, so it doesn't really make sense to peer on the loopback. Although I understand the reasoning, they want us to make sure that we get this down. So we know that we're going to be using the update source. That's going to be the IP in the neighbor statement on the other side. And we need to have a static route. So let's go ahead and knock that out right here on Gateway 1. And let's see, show run section BGP. Do we have anything set up? We've got nothing set up, so this is going to be good. So we're going to go from privilege exec to global config. Let's knock out this IP route first. What is the loopback 0 address? Show IP interface brief. It should be 192.168, or I'm sorry, 209.165.201.21. So that is the loopback 0 address that we're going to be peering with. So I'm going to go ahead and say IP route. So to get to the 209.165.201.21 address, and we'll do a host route here. And it stopped typing. 209. There we go. .165.201.21. So to get to that address, and we'll do a host route, my next hop would be 209.165.201, and I believe it is .2. Yes. Yep, Ethernet 01. .2. All right. So there is my static route providing me, and let's test it out. Do ping 209.165.201.21. All right, fantastic. We've got that connectivity. In fact, I probably should have done this first. Pull the route out, test the reachability. Is it there? It's not there, right? And so this kind of proves that we don't have reachability over to that loopback address on the ISP1. So let's put our route back in. Let's test our connectivity. All right, everything is perfect. So now on to the heavy lifting here. We need to have our BGP section configured. So I'm going to say router BGP, we're 65,000. Now, I'm going to say no default or no BGP, default IPv4 unicast. Now, this is very important in the book. It was in the gray highlighted section where they had a typo in there. They referenced a command that said no BGP default IPv4 activate. That is not actually a command that exists. I've checked 15.3, 15.4, and 15.5 code, and there is no IPv4 activate. It's IPv4 unicast. Okay? And what this is going to do is when we go, if we use multi-protocol, and I'm assuming we may be doing some IPv6 here down the road, if we set that up, you have to manually activate the IPv4 peerings. They will no longer auto-magically be activated for us. When as I run that command right there, now we've got to manually activate it. So let's go ahead and we're going to need to put in our neighbor statements here. And I need to see the job aid real quick. Okay, there's that loopback 0 address. So I'm going to leave the job aid up while we do this. Let me squeeze. I don't want to go too far. All right, so we'll leave the job aid up. So I'm going to go with the multi-protocol setup. I'm not sure we're doing v6 or not, but let's just stick with that. So in the global area, neighbor 209.165.201.2. I'm sorry, we're peering to the loopbacks. I almost made a critical mistake there. So remember, the loopbacks are what we're peering to here. So .21, and the remote AS is 65.100. We're going to redo that, and we're also going to say update source is loopback 0, right? So I want to make sure that the address that the ISP1 router is peering to on gateway 1 is my loopback address, so I'm putting that update source in there as well. Remember, those have to match. You'll see the peering is not up yet, right? We don't have the peering up yet, even though we've got reachability. So why is the peering not up? Exactly. The last thing we're missing that they conspicuously put in here when they peered in, they put eBGP multi-hop 3. Now, does it need to be 3? What do you think? No, we need to have that eBGP multi-hop statement in here. So, but it only needs to be, and I'll just put eBGP multi-hop. It only needs to be the equivalent for the number of hops we are away. So by default, the time to live in the packets for eBGP peerings is 1. So if I say do show IP BGP, I have nothing, right? I have no neighbors, nothing. And the reason is because that command right there, the eBGP multi-hop, I need to make sure that it is at least 2 hops away. So because the loopback address to which I'm peering is going to be 2 hops away. And let's make sure, so do show IPBGP, and I'm wondering if they want me to match, if it has to match up. So it should work with 2. We'll put 3 in. And let's see what happens here if I'm missing anything else. Let's say do show run. Oh, so I just forgot. I'm going to change it back to 2. So why is it not coming up? Do show run section BGP. You've got it. We have to activate it. So this is proof that it doesn't activate it by default. So let's say address family IPv4. I don't have to say unicast because that is the default. I bring my neighbor statement back. and then I'm going to say activate. So I've set the multi-hop to 2. Excuse me. Because again, to get to that loopback address, it should only be 2 hops. Oops, sorry. It should only be 2 hops away, and there you go. So it doesn't need to be 3. For some reason on the ISP, it was set to 3, but it only needs to be 2. And as you can see, the peering is up. So do, and we'll do the new commands, do show BGP IPv4 unicast. So there we go. And as you can see, we've actually learned a single route that's at 203.0.113.0 network, which we're picking up from up here. It originated, and we can tell the originating AS is the far right-hand side. It was originated with the network statement because of the I. So it originated in AS 65300, came through Autonomous System 65100, and it is valid and best. So let's check. Do we have connectivity? Do ping 209.165.201. Not 21, sorry. I'm all over the place here. 203.0. I was going to the next hop. 203.0.113.113 dot and 23.23. And let's check it out. Do we have reachability? So why do you think this might not be working? Good. If you're thinking that I didn't source it from the loopback address, you're absolutely right. Because remember, on the ISP router, does he have a route back to the default source address? And remember, the default source address of the ping packet, and this was Deborah's question, is going to be the outgoing interface. And so that is the interface that's going to be going out. All right? So let's clear that. Come back over here, and let me say show IP route. Do you see a route here for 209.165.201.0? Very similar to the discovery activity 23, we do not. Right? So therefore, there's no reachability. However, and in fact, I don't even have, I'm probably going to originate something here in a second is my guess. But I don't even have a route to any of the 192.168. So none of the loopbacks. So that may be coming up soon. Let me drop back to the scenario here real quickly. The external BGP service have loopback interface to the routers. The session from ISP2 to Gateway 1 and Gateway 2 should be established between directly adjacent IP addresses, which is typically what you would see. You must ensure reachability. So this is a perfect example of how Cisco will phrase things. You must ensure reachability to the external IP address, 203.0.113.1, which is going to be the IP address, and let's go back to the job aids, 200.103.0.113.1. So to the loopback 1 address up here on, and I apologize there, that's the last video burning, to this loopback 1 address. So we just took a look at that, and we know that in order to do that, we need to have reachability back from ISP3. So let's go ahead and on Gateway 1, let's originate with the network statement here. Let's do the .11, I think is the one we did before. So network 192.168.11.0 with a mask of 255.250.250, 255.0. So I'm going to originate that network. Let's go to ISP3, and now let's take a look here and see, do we have a BGP learn route? We do, and it's to that 192.168.11. So now, back on the gateway router, if I rerun that ping I ran earlier and source it from loopback 1, do we have reachability to the 203.0.113.23? Let's make sure that's right. That may not be the right address. That's the network. Let's check it out here. Loopback. Where is that loopback 1? It's .1. All right, so do we have reachability to, let's get the right IP address in here, .1, and we do. And again, it's because we had to advertise our loopback, which is the address that we were sourcing the ping from. And to reiterate, you typically do not advertise the transit network links because, again, you're not routing to that interface. You're typically routing to a network behind that interface. And so that's why, like I say, that OSPF prefix suppression command exists in OSPF. You're typically not routing to the transit network interfaces on the routers. You're routing to a network that's behind them. And so that's why we advertised, I mean, we could have advertised this network, right? The directly connected network right here, I could have advertised that out. But we don't want to do that because it's the transit network. We want to advertise the actual network that you would be trying to get to. Okay, so we've got that all taken care of. Let's knock out this eBGP config right here between gateway 1 and ISP2. So I'm in the address family. So let me come out to the global area where we're going to say neighbor 209.165.201.18. So .18. And the remote AS for this guy is, I think, 65,200. It is. Remote AS 65,200. Now you'll notice the peering doesn't come up automatically, right? So if I went over here to ISP2, and let's take a look at how he is configured. So show run section BGP. He has all of the information for the .17 address. He's ready to go, right? Because we're peering not off loopbacks, which is why we don't see eBGP multi-hop. We don't see the update sources loopback 0 address. We're peering off of the directly connected networks. So the TTL of 1 is going to work fine because we are 1 hop away. We are that directly connected network away. So why is the peering on gateway 1 not coming up? Well, let's take a look. Do show run section BGP. You've got it. We haven't activated that network yet. So that neighbor relationship yet. So address family IPv4 unicast. So we'll pull back the command we just ran and we'll drop this back here and we will say activate. And now you will see, and we'll give it a second here, BGP is not the quickest of protocols, that this peering is going to come up. So do show run section, and there we go, right on cue. So now the peering between router or gateway 1 and ISP2 has also been taken care of. All right, so let's take a quick look at the scenario here again. All right, from ISP2 and gateway 2 should be established using directly ensure. So now let's take care of gateway 2. So we haven't done anything on gateway 2 yet. So we jump over to gateway 2 and let's take care of the reachability between gateway 2 and ISP2. So we'll go from user exec to privilege, user exec to, gotta click in there, user exec to privilege exec into global config. And again, we're peering off the directly connected networks. No need for a static route. No eBGP multi-hop. No update source loopback 0 because we're not using the loopback addresses. We're using the directly connected networks, and so those are known already. And we have a TTL of 1 by default. For eBGP peerings, this is going to work great. So let's jump in with just straight up router BGP 65,000. The first thing that we're going to want to do is BGP. I always like to log neighbor changes, and then again, no BGP default IPv4 unicast. So we want to have full control over what neighbor adjacencies or peerings are activated and when they're activated, and then we can deactivate them. And again, it's good to keep full control over them. And if you go into multi-protocol BGP, you're going to have to make sure that with the IPv6, if you didn't run that command right there, if I went ahead and said let the IPv4 neighbor relationships activate automatically, with IPv6, that's not the case. So you have to activate the IPv6 portion. All right, so let's go ahead and do this. We've got the BGP statement, so let's get our neighbor statement in here. So 209.165, 201 is at .5.6. So 201.6, and then we're going to say remote AS is 65,200. And then let's originate that loopback 1 address. Remember, we've got to provide, it's up to us to ensure full reachability. So when I ping or trace up to this loopback 1 address, we need to make sure ISP3 as well as 1 and 2 learn about my loopback. And actually, I need to go into address family, IPv4 unicast, to do this network statement for the 192.168.22.0 with a mask of /24. So let's come up to ISP3. Has he learned any new information? Right, update's not here yet. So we'll wait for things to update. Let's check ISP2. Does he see the update? All right, ISP2 does not see the update yet. Let me make sure. Let's go back to Gateway 2. So do show iBGP. So there's the network statement, and it should have been picked up. Do show run section. Did I put that in IPv6? I did not. So we've got our network statement there. We've got the peering statement there, so we should see that. Yeah, so that is interesting. Why are we not seeing that? So let me think about this for a second. We've got the network state. Oh, did it? No, the mask, is it the wrong network? Let's check on Gateway 2 here. Let's see. Did I even get the IP right? 192.168.22.0/24. So let's say do show IP interface brief. And there it is. It is the loopback 1 address. It's up. So do show IP route. Is it in the routing table? It is. It's directly connected. It's up. So do show run section. Oh, I keep killing myself with this. So I'm showing you how to run this no BGP default IPv4 unicast command, telling you over and over again that you have to activate the neighbor statement or the neighbor relationship with a neighbor statement. So why don't I put that in there and say activate? And again, fortuitous failure, right? Forcing me to come back, take a look at the BGP config, and now say do show run section BGP. It would have helped if the neighbor relationship had been up. So now when I come to ISP2, let's click in here. I come over to ISP2. Now we see the 192.168.22. And if I go to ISP3, we're going to have the same success. So now from Gateway 2, do I have reachability? Do ping, and what is that? I'll do a little sneak peek here. 203.0.113, 203.0.113.1. It doesn't work, right? Because again, it's sourcing by default the source IP address in the ping packets. By default, it's going to be the outgoing interface. That is not a route or a prefix that ISP3 has. So I need to source this from the prefix it does have, which is my loopback 1 address. Okay, so that takes care of the eBGP work, I believe. Let's take a look at our scenario, and we should be good. So Gateway 1 and Gateway 2 should advertise. Oh, yeah, okay, great. So we got that. You need to make sure that the enterprise does not become a transit AS. So in order to make sure that it doesn't become a transit AS, have we protected ourselves from that? We have not. So let's do the iBGP. Let's make sure to reach the next hop IP address is advertised. So we can use either a routing protocol for that reachability here, an IGP like OSPF or eIGRP, or I can just use, without adding additional networks, to the IGP that runs between Gateway 1 and Gateway 2. All right, so we could go with statics. And let's check and see. It may actually be, are we running between Gateway 1 and Gateway 2? I'm going to check to see when I say do show IP route. Let's check to see. Okay, so we are running OSPF, and we do have reachability. So that's why it says, okay, without adding additional networks to the IGP, so we are not going to put a static route in there. We're going to just leverage it off of what we already have. So let's do our iBGP config. So let's go to the global BGP config section, and let's say neighbor, and we're going to go ahead and say 192.168.2.2. And that's the route we have in OSPF, and the remote AS is going to be the same, 65,000. And now we're going to say, let's go into the address family IP. Or actually, before we do that, we're going to have to do the peering portion, which is going to set the update source to the loopback 0 address. And I want to say, pull back the update source, we want to say next hop self. Come on now, next hop. Oh, I got to get into the address family for that. My apologies. Address family IPv4. So we'll pull that neighbor statement back. And now it likes that neighbor statement. But we have to activate the neighbor first. So we'll activate the neighbor, get the next hop self in there. And now do show run. And we'll say section BGP. We can see that everything is set up for that iBGP peering now. So now we need to reciprocate over on gateway 2. We need to do the same thing. So let's come out of the address family. Let's go ahead and put in the global config area. The 192.168.1, oops, .1.1 is what it's going to be. 192.168.1.1. The remote AS is our AS 65,000. It's an iBGP peering. So then let's go ahead and add in the update source is loopback 0. Drop into the address family IPv4 unicast, and we're going to pull the address family or the neighbor statement back up. We're going to activate this, and then I'm going to say next hop self. All right, so let's look at what we have now. Do show run section BGP, and there we go. So everything looks good for the iBGP peering between the two internal routers. So I need to influence inbound. All right, fantastic. So we're going to get an opportunity here to do a couple route maps, and let's see if there's any limitations here. So we need to influence inbound and outbound path selection. So we know what we want to use, right? For inbound path selection, we want to use AS path prepending. For the outbound path selection, we want to use local preference, because those will be communicated to the other autonomous systems. Well, I should say the AS path will. The local preference will be communicated to the other iBGP peers. So the link with ISP1 is the most preferred, followed by a link between Gateway 1 and ISP2. So then the final slowest links will be between Gateway 2, should be used as a last resort. You're allowed, so here's our restriction, you're allowed to add a maximum of a single AS number occurrence to any AS path. So this is going to be interesting. So let's think about this for a second. So we know what we're going to do. We're going to do local preference. It doesn't say we can't use local preference, and we certainly don't want to use wait. You would never use wait in a scenario where we're multi-homed, right? We've got multiple things going on. We've got two iBGP peers here. So this is screaming to use local preference. So the outbound selection, remember, it said that this direction to ISP1, that this is going to be our number 1 choice. That is going to be our number 2 choice. And this is going to be our default, or our last, the default, I shouldn't say default, that's probably not a good approach. This is going to be the lowest, and the default value for the local preference is 100. So let's do this. We're going to set number 1 to 9999. We're going to set number 2 to 8888 in terms of the local preference value. Remember, it's a 32-bit value, but we don't want to get carried away. I just want something in there that is definitely higher than 100, that stands out for the value that, and in fact, I guess I could do, let's do this. Let's make it meaningful. 1111, because that's going to be, well, that ain't going to work, is it? I'm making this too complicated here. So we'll stick with our 9999 or 8888. All right, so we know that we're going to have to do a route map to deal with this. So let's go ahead. I'll leave that up over there. Let's go to Gateway 1. And on Gateway 1, let's get this set up. So I'm going to exit out here, and we're going to say route map, and we're going to call this LP for local preference. And I'm going to say permit 10. And the first thing I'm going to do is I'm going to say set local preference, and we'll set it to 9999. And that's going to work well. And then we're going to say route map. What did I call it again? Where is it at? LP for local preference. route map permit 20, and we're going to set the local preference to 8888. And then that's it, right? So now let's go ahead, do show run section BGP, right? So we need to apply this route map to both of our neighbor statements. So router BGP 65,000 and address family IPv4 unicast. I'm going to say neighbor, so to the 209.165.201.2. So that's ISP. Oh, we're peering off the loopback addresses. I need to remember that. The 21. So we're going to apply the route map LP in. And in fact, you know what? I need 2 route maps now that I'm looking at this. So before I run that, whoops, say Control U, Control C. There we go. Before we do that, let's go back into global config. I'm going to say no route map LP. No route map LP. So let's say we'll call it route map. Take a better approach here. We'll say ISP1 permit 10, and I'm going to set local preference to 9999. And then let's say route map ISP2 permit 10, and we're going to set the local preference to 8888. There we go. So now we've got 2 route maps, and I overlooked that when I got to the neighbor statements that we don't want to reference the same route map. So address family IPv4, and so for neighbor, and let's use those loopback addresses, 201.21, I'm going to apply the route map that sets my local preference so that it prefers ISP1. And remember, with local preference, we want it in the inbound direction. So now let's set it for the other route map on the neighbor statement for 209.165. What is that? 201.18. Let me double check, make sure. Yeah, 18. .18. We're going to apply route map. What do we say? ISP2. And again, it's in the inbound direction. So routing information that I'm learning from these routers is going to have this route map applied, setting the local preference on that information we're learning. And then I don't do anything for the link to gateway 2, right? That's an iBGP peering. I'm just leaving it as the default. All right, so we've got that set. So let's say do clear IPBGP star. And we're going to do the same thing over on, well, actually, we don't have to. So we don't actually have to set this on Gateway 2. We don't have to do the local preference setting because Gateway 1 is going to communicate that information to Gateway 2. So do show BGP IPv4 unicast. All right, so it looks like we're waiting for things to be sorted out here and to determine who's best and who's valid and how they're being learned. All right, so there we go. So on Gateway 1, you can see we've got things sorted out here. And so let me ask you this. So here you can see that this is valid, but it's not the best. Why is the route to 201.0.113.0 out ISP2 not the best? I'm sorry. Yeah, why is it out ISP2, which is that .18 address? Why is that not the best? So the best is out the 21 because it has a higher local preference. Remember, the very first thing we look at is the weight. The next thing we're going to be looking at is local preference. And so that ensures that we don't try to go out ISP2 to get to that network segment. So now we've got the outbound under control here. Let's do a quick trace. If I were to say do trace to the 203.0.113.1, you can see that it's going to fail. And why is it failing? I need to make sure that I source it off that loopback 1 address. So we go to 209.165.201.2. We go to ISP1 and then up to ISP3. We've got full reachability. So now we need to influence the return traffic. So if I come up here to ISP3, and let's get logged back into ISP3 here. We haven't been on ISP3 in a while. If I say show IP route, let's see the routes that we've learned. And what do we see? We see that ISP3 for both of the loopback addresses, for Gateway 1 and Gateway 2, wants to go to our old friend ISP2. Now, that's not what we want. We want to influence the return traffic to come back to us through the same path that it left out of our enterprise, which is Gateway 1. And so this is going to mirror the setup we had earlier. So let's go to Gateway 2. And on the Gateway 2 router, let me go ahead and type exit, exit. So we're going to do a route map here. So I'll say route map, and we'll call this route map AS prepend. So ASPP, and we're going to say permit 10. And what are we going to set? We're going to set the AS path prepend. And remember, the limitation we have is that we can only prepend a single autonomous system. So I'll just say AS path prepend 65,000. Again, the previous one I prepended 5 instances of the AS path. So now what do we need to do? Well, now we need to get back into that router BGP 65,000 global config. I need to get into the IP address family IPv4, and who am I going to be communicating this information to? Well, I'm going to be telling, and give me 1 second here. Let me double check the scenario. You need to influence the link with ISP1 is the most preferred, followed by a link between Gateway 1 and ISP2. The slowest link should be between Gateway 1 should be used number as a last resort. All right, so okay, this is actually going to be a little more complicated. These challenges actually are a little more complicated than the normal activities. So we need to do this, but we're also going to have to affect the metric. Yeah, so we're going to have to do the, because we can only okay, so now so it's becoming clear to me why they're saying you're limited to prepending 1 instance. So we're going to have to think outside the box here on Gateway 2. So for the return traffic, I'm going to do the med. Where are we at? Where's the job list here? Or the job aids? All right, so on Gateway 2, we're going to do the AS path prepending, but we also, with this neighbor, ISP2, we're going to prepend 1 AS, but we're also going to communicate the med value, the metric value, to have it swing that way. And if we look at the selection criteria, let me explain that. I'm sorry, I'm thinking this through as I'm looking at it. So the reason we're going to be doing that, right? So number 1 is the preference, the weight. We're not dealing with the weight. It's a locally significant value. Number 2 is what? Highest local preference. This is for outbound. Again, for inbound, prefer the path that was locally originated. We're not dealing with that. Prefer the path with the shortest AS path. The origin code is going to be the same because we're using network statements. And then here it is. Prefer the path with the lowest multi-exit discriminator. So we're going to have to combo this up here. Pull the Learning Labs back here. So let me slide this. Actually, I got a little carried away there. Let's keep this over here. So not only are we going to have to set the AS path prepend out to put 1 instance of 65,000, we're going to have to tell ISP2 that the med is going to be 20 so that it does not, because the AS path length, when we prepend, right, they kind of walk us into this where we prepend 65,000 once, but we're going to do it over here as well on the prepend toward ISP2. So yeah, that's right. So because again, this is actually, these are good. I like these activities. So the scenario, let's take one last look here. Let me clear my screen. Whoops, let me clear my screen. And that is definitely not what I wanted to see there. So we cleared the screen. So the link with ISP1 is the most preferred. So we're good there. Followed by the link, by a link between gateway 1 and gateway 2. So yeah, so we're going to prepend 1A. Okay, so I see how we're going to deal with this. So we are not prepending, no prepend, going this way. Man, this is a great activity. No prepending going to ISP1 because we want this to be the path in to us. We want it to be the best path out. So local preference took care of that. Now, this is supposed to be the second most preferred. So we're going to prepend one instance of the AS path, 65,000 here. Well, if we do it there, we better do it here too, or else that would be the second most preferred, and we don't want that. So this is going to be the last preferred. So we're going to prepend 65,000, but then we have the same AS path length, right? We go back to actually, let me clear the screen here. We go back to our selection. If prefer the path with the shortest AS path, once that's the same, the origin code is next. That's going to be the same. Prefer the path with the lowest med. And so the metric by default is going to be 0. So we're going to set it to 20 or something other than 0 to make this final path back, set the med to 20, because the AS paths will be the same length. We're going to have to throw the med in here as well. So before my session here on that times out. So yeah, this is going to be a doozy. So address family IPv4. I'm going to go ahead and bail out of here right now. We need to go back, do show run section route map. So we need to prepend. So route map AS path prepending. That's probably not the best name at this point. So let me do this. We're going to start from scratch. So I'm going to say no route map ASPP. And we're going to say route map, and I'm going to call it ISP2 because that is who I am peering with. So we're going to say permit 10. So I'm going to set AS path prepend to 1, right? To one instance of the AS. However, I'm also going to set the metric to 20, or actually, what can we do? Is it the lowest metric value? We'll set it to, let's just say we can set the metric to 50. Now, once we have that set, now we can jump back into the router, BGP 65,000, address family IPv4 unicast, and here is where we're going to say neighbor 209.165.201 dot, and it was, I need that job aid back, .6, 201.6. And this is where I'm going to say route map, and we called it ISP2. And what direction do we want to do this in? In the outbound direction. Because the med and the AS path prepending are going to be done in the outbound direction. So if I were to come over here, and if I were to say show iBGP, you can see that we have the different routes that are here. Again, I haven't cleared anything yet. We still need to have some work on gateway 1 that we need to do. But right now, you can see that the metric value by default is 0. So let's go ahead and go to gateway 1, and let's take care of gateway 1 as well. So we're going to have to prepend here to get it to work. So we'll just say route map, and we'll just say PP for prepend, permit 10, and set AS path prepend 65123. Again, this is a phenomenal activity when you work through it. And that's it. That's really all we need. Let's get in the router BGP 65000, address family IPv4 unicast, and we're going to say neighbor, remembering that this is going to be the prepend route map is going to apply to ISP2, to whom we're peering 209.165.201.18. And then route map prepend. All right, we didn't call it, let's say PP, sorry. Route map prepend, or PP for prepend, outbound. All right, so I'm going to go ahead and say do clear iBGP star. We're going to go to gateway 2, and we're going to say do clear iBGP star. And again, this is not something that you do during the middle of the day, right? This is not something you want to do during the middle of the day. All right, so we've got that set up. So now let's take a look on gateway 1. Let's validate do show iBGP. Hopefully, well, nope, we're still converging. So we'll give it some time. And so what we should see is the preferred path out and in to the AS 65000 autonomous system is going to be through gateway 1. And we're adding some information in here, and BGP is doing its thing. Whoops, we don't want to clear it again. All right, there we go. So when we take a look at this, what do we see? We see that the best path to the 203.0.113.0 going to 18, this is gateway 1's view, this is not the best. The best is outbound to the 209.165.201.21 because we have a higher local preference than the ISP2 path. So that works out great. So we can validate that very easily by simply saying do trace 203.0.113.1, and again, keep forgetting to source this guy from our loopback 1 address. And so we've got reachability there. So now let's go up to ISP3. We may have to clear the BGP session on ISP3. I hope not. So let's go from user exec to privilege exec into global config. And let's say do show IP route. And it looks like we're in good shape. So we've got our BGP routes back. Let's say do show iBGP back to AS 65000, and it looks like the next hop for those is going to ISP1. And so if we come back here, you can see the valid and best is to ISP1 because again, take a look at the prepending we have here. 2 AS paths to go that way, 3 AS paths to go to 13, which is ISP2. And that's why that is the best. Same thing here, right? To get to the 192.168.22, which is gateway 2's loopback, we don't go to 13 because it has 3 AS numbers in the path. We're going to go to ISP1 because there's only 2. And we can confirm this with a very simple do trace to 192.168.11.1, and let's source it from the loopback 1 address, and there we go. We go to ISP1 and then into the gateway. So now the interesting thing to look at, let's go take a look on ISP2. Let's see what ISP2 sees. So show iBGP, and ISP2's got a lot of stuff going on here, and let's see what this tells us. So you can see here, it doesn't prefer the path to gateway 2. It also doesn't like the path to the 201.14, which is back up to ISP3. Sorry about that. Had to pause there. Back to ISP3. Which path does it prefer? It prefers the path directly to gateway 1. Do you see that? And let's take a look again here. Right? The preferred path is what for ISP2? Is it to go to ISP3? No, because it's not best. Is it to go directly to ISP1? Yes. Is it to go back to gateway 2? No. So again, you can see that that gateway 1 is being selected as the best way to go. And this was helped out when we set the metric, the med, to 50, right? Because the lowest metric wins. And we're setting it to 50, and that is not as good as 0. So we're making the path to us, and this is gateway 2 here, we're making the path to gateway 2 from ISP2 look even worse because we're setting it to 50. Therefore, it will choose off the lowest, or actually the AS paths are equal. Do you see that? So when the AS paths are equal in length, the tiebreaker, lowest med, and 0 is less than 50. All right, so now we're going to revisit the last thing that we had to do, which is to make sure that we're not a transit. And so what we want to do is we only want to accept locally originated routes. And so this is screaming AS path access list, and the book had a great example. And where was that? Yeah, right here. Gateway 1 and Gateway 2 should advertise to ISPs their loopback 1 interfaces. However, you need to make sure that the enterprise does not become a transit AS. So on Gateway 1 and Gateway 2, we're going to do that AS path access list. And let me exit out here and exit out here. So IP AS path access list 1 permit. And what are we permitting? We only want locally originated information. And remember, that's the beginning of line, end of line sequence with the regular expression. And what that means is that only locally originated routes are going to be, we're going to set it up so that that's all that's advertised out, that we're not advertising some other ISP's routing information. In fact, let me go ahead and set that. So before I look at anything, if I say do show iBGP, you can see that we actually have the 203.0.113. We don't want to re-advertise that information back out and then have other ISPs coming to us to get to that information. So we configure that access list saying only advertise the locally originated information. So I'm going to say router BGP 65,000. We're going to go into the address family IPv6 unicast, and I apologize, IPv4 unicast. IPv4 unicast, and we're going to throw this onto the do show run section BGP. It's going to be for router 1, it's going to be twice we're going to have to use this because it's, let me flip back over here to the job aid. So remember, our gateway 1 is paired with ISP1 and ISP2, so both of those neighbor statements will need that. So let's say neighbor 209.165 201.18, and that's ISP2, and we're going to say filter list, and we use just 1 in the outbound direction. Let's do the same thing for the 201.21, which is ISP1, and then I'm going to clear that. Let's say do clear iBGP star. We'll come over to gateway 2 while that is churning away. And we want to do the same thing. IP AS path access list 1, and we're going to say permit, and the caret $. So that, and basically that's the absence of an AS path number, because we don't want to re-advertise other AS information that we're learning. And so that caret $, basically just says the absence of an AS path number, which equates to locally originated information. So router BGP 65,000, address family IPv4 unicast, and we're going to say, actually, what is my neighbor? Do show run section, not neighbor, section PGP. All right, and it is .6. So neighbor 209.165.201.6. Yeah, that's correct. Yep. And we're going to say filter list 1 out. Do clear IP BGP star. And let's go ahead on gateway 1 here and see if we've reconverged. So show IP BGP. All right, everything looks good. And we should only be advertising. If I come over to gateway, I'm sorry, not gateway 1. Let's come over to ISP1 and let's say show IP BGP to see the information I'm learning. And what you'll see is the only information I'm advertising is my 192.168.11.0. That's all I'm advertising to the ISP. He's learning about this from ISP3. And so I've guaranteed that my routing information is the only information that I am originating. I want to roll back here, and did I not have? Yeah, I didn't have. I wish I would have had another show IP BGP to see if it would have showed that we were advertising information maybe being picked up over here on ISP2. Let's see ISP2, show IP BGP. And everything looks good there. So let me look at the scenario one more time. So we've got the peerings, we've got the ISPs, we're not a transit. So this should do it for this activity. All right, well, this is going to wrap up challenge 10 for configuring BGP. And man, this was a great challenge activity. These learning lab activities are absolutely fantastic, start to finish. So definitely spend some time and definitely understand. And I thought that, boy, it really took it to the next level there when we had to come up with that route map that not only did the prepend, but set the metric over here on gateway 2 to make sure that gateway 2 looked worse. Section route map, right? That route map right there. Right, that for the outbound information going to ISP2, because the AS paths, they really walked us into that, making those AS paths the same length, forcing us to think, okay, after the AS path, what's the next thing that's going to get evaluated? And it's the metric. All right, I will see you guys tomorrow.